Let's talk about polar curves, polar coordinates, and calculus. First, we'll do a quick sort of intuitive introduction to polar coordinates, and then we'll get into it in a more mathematical way. Let's say you're driving along a road somewhat slowly, maybe because there's deer warning signs up, and you see a deer out here, world's best picture of a car. I'm not even going to try to draw a deer, so let's say it's there. How would you describe, let's say you're the passenger and you need to tell the driver where the deer is relative to your car. So you might say it's ahead off the side of the road or something. If you needed to give a more precise description, you might say it's at 1 o'clock, like where the where the hands would be at 1 o'clock on an analog clock. So you might say it's at 1 o'clock, and you might say how far away it is, like 30 meters out. Let's say 25 meters out. So using that, would the driver know basically where it is? I would hope so. Let's talk about this 1 o'clock system. If we're looking at a clock face, we've got 12, 1, 2, 3, we've got 6 down here, we've got 9 over here, right? And how much of an angle is this from 12 o'clock to 1 o'clock? That's 30 degrees. And then another 30 degrees to 2 o'clock, or you could say 2 o'clock is 60 degrees from noon. So there we're using kind of the compass coordinate system where north is like 0, south is like 180. According to this statement, we've got the deer at 30 degrees from straight ahead and a distance of 25 meters from the origin out to there. So that's an intuitive way of talking about where something is relative to your current position and heading. Let's talk about it the way we actually do things mathematically. We do it in more the unit circle trigonometry kind of orientation. And of course we use radians. So we base it on not straight ahead being 0, but the positive x-axis being 0, a 0 angle. And then we increase counterclockwise. So how would we describe where this deer is according to that system? We'd say instead of describing this angle, we'd describe this angle, which if that angle is 30, this angle will be 60 degrees, but in radians that's pi over 3. And then we'd say 25 meters of a radius from the origin out to that spot. Okay, and that is an ordered pair, an angle and a distance. So we can write it as an ordered pair. But for interesting reasons, we usually put the radius first and then the angle. So we'd say radius equals 25, and for angle we use the Greek letter theta. I'll write it here. Theta is pi over 3 in this case, or we just write 25 comma pi over 3. It's not a bad idea when you're first getting used to this to writing r equals this, theta equals that, so you can get used to which is in which position. Let's talk a little more about plotting ordered pairs or points in polar coordinates. So there's two views of it. It's good to have both views in mind. One will end up being a little more handy for the calculus we want to end up doing. We could say that first you go out along the x-axis for the designated radius and then turn at a designated angle. So out along x-axis for r units. Then turn by theta radians. So that would say, like if I wanted to go out 25 millimeters and then turn pi over, let's see, here we go. So I'd say, okay, I'm going to go out to 25 millimeters, and then I'm going to take that whole thing and pivot it up until I'm at pi over 6, pi over 3. I'm drawing that line there, but really it's just that point that I need to draw. And pretend that I managed to get the axis there. The other way to think about it is that I'm going to turn by theta radians first, and then go out along that ray for r units. So there I'd say, okay, I'm going to turn 60 degrees, which is pi over 3, and then I'm going to follow that line out here to 25 millimeters, and I'm going to do that. So both of those are good ways of thinking. It turns out that number 2 is better for the kind of calculus we're going to do. Option 2. And then in the next video, we'll try some, like given some points, try figuring out their r and theta and stuff like that.